Hi, welcome to the video on using the mole map to solve mole problems with dimensional analysis. So for this video, I'm going to go over several examples. Here we have a mole map, which is our tool that we use to help us pick the conversion factor to convert from our given and find. And here are the steps. We first identify our given and find, then we use the mole map to pick our conversion factor, and then we set up and solve via dimensional analysis as shown here. So looking at the first problem, it says how many moles of H2O are there in 61.27 grams. So my given is 61.27 grams, and what I'm asked to find are the number of moles. So now I'm going to go to my mole map and figure out which conversion factor I'm going to use for that. My given is mass, so I'm starting here. Grams is a unit for mass, and I'm trying to get to moles. So that means the conversion factor I'm using is 1 mole is equal to the molar mass. Now the molar mass you actually have to calculate before you can go any further from the periodic table. Okay, we're using the average atomic masses in the periodic table. Since this is water, which is H2O, the molar mass for water is going to be 2 times the average atomic mass of hydrogen, which is 1.01, plus the average atomic mass for oxygen, which is 16.00, and 2 times 1.01 is 2.02, plus 16.00 gives me 18.02 grams per mole. All right, so now I can set this up as my conversion factor. My conversion factor is then going to be 1 mole equal to the molar mass of water, which is 18.02, and then now we're going to change the units to grams because we're saying 1 mole of water is equivalent to 18.02 grams. All right, so I've done the first 2 steps. Now I'm ready for my setup. For the setup, since I have 1 conversion factor, I'll be multiplying 2 fractions. In the first fraction, we're going to put our given, 61.27 grams. And if you want to, you can put it over 1. And then in the second fraction, we're going to use the parts of our conversion factors, keeping in mind that we want to cancel out grams so we can convert it to moles. And in order to cancel out the units of grams in my given, I need in the second fraction gram to be in the denominator. It needs to be opposite position to cancel, because when they're opposite positions, when you're multiplying fractions, you're going to divide them out. So they'll cancel. So I'm going to take the 18.02 grams and I'm putting it in the denominator so that these units are now opposites and will cancel out. And then I take the other piece of that conversion factor, the 1 mole, and I put it in the numerator. And now I have my setup and I can do my math. So this is 61.27 times 1, which is 61.27, divided by 1 times 18.02, which is 18.02. And when I divide out the 2 numbers, I get 3.400 moles. And the reason why I have this many decimal places is because of sig figs. If you're not doing sig figs and you have 3.40 moles, that's fine too. All right, next one. What is the volume of 0.75 moles of an ideal gas at STP, standard temperature and pressure? So my given here is moles, and I'm looking for the volume of a gas at STP. So when I go to my mole map, I'm starting here at moles, and I'm trying to go here to volume. This is my conversion factor. So again, I have 1 conversion factor, so for my setup, I'm multiplying 2 fractions. The 2 fractions will be starting with our given, 0.75 moles, over 1 if you would like. Second fraction, I'm using the 2 pieces of my conversion factor, 1 mole and 22.4 liters. Since my given units are in moles, I'm going to take the 1 mole, that part of the conversion factor, and putting it in the denominator so that the moles are opposite so they can cancel out. And then 22.4 liters goes on top. And so my math here is really simple, 0.75 times 22.4. And when you multiply that out, you get 16.8 liters. For example 3, how many sodium atoms are in 0.4 moles? So 0.4 moles is my given. We're looking for the number of atoms. That's what I'm asked to find. So I'm starting with, on my mole map, I'm starting at moles. And now I'm going to number of atoms or molecules, right? So this, in this case, my conversion factor is 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23. And that's my conversion factor. All right, I have one conversion factor, so I'm going to multiply two fractions. In the first fraction, we're going to have our given, 0.4 moles. In the second fraction, I'm going to take the 1 mole, and I'm going to put it in the denominator, so moles are opposite, so they can cancel. And then I take Avogadro's number of atoms, 6.02 times 10 to the 23, and I put it in the top. So now it's time to do the math. I'm just going to multiply these two numbers. This is just a number in scientific notation. If you're using a TI-30 calculator, remember to put this in. I have 0.4 times, and then for Avogadro's number, I do 6.02, so I'll do the coefficient first. And then instead of doing times 10 with the caret, you can use second, these big E's here, these double E's. So that is your times 10, so all I have to do is put in the power, 23. All right, I don't need to do times or a 10 here if I use that. And then this will give me the answer, and it's giving to me in scientific notation 2.408 times 10 to the 23, which if we're using sig figs, will just be 2 times 10 to the 23 since I only have one sig fig here. And don't forget the units, atoms. Okay, next one. How many sodium atoms are in 20 grams of sodium? So my given here is grams, and I'm asked to find the number of atoms. So I go to my mole map. I'm given grams, so I'm starting at mass, and I'm trying to get to the number of atoms, but I can't get there directly. I have to go through moles. So the first thing, I'm going to go from the mass to moles. I'm going to use this conversion factor first. Then I'm going to go from moles to number of atoms. I'm going to use this one second. So I actually have two conversion factors in this case. So 1 mole equals to the molar mass of sodium. And the good thing about this one is sodium is not a molecule. I don't have a chemical formula that's the molecule, so I'm just using this number. So 1 mole is equal to 22.99 grams. That's my first conversion factor. The second one is going to be 1 mole equal to Avogadro's number. Now since I have two conversion factors, I'm going to be multiplying 3 fractions. All right, and the first fraction is my given always, so that'll be 20.0 grams. And then in my second fraction, I'm going to put my first conversion factor. So since I want grams to cancel out, I'm going to find the part that has grams, 22.99. That goes in the denominator. Then I take the 1 mole and I put that on top, so grams cancel out. And now the unit I have are moles. So now for my second conversion factor, I want to cancel those moles out. So I'm going to take the 1 mole, because they're focus on the units, not the number. Since the units match, they have to be opposite to cancel. So now moles cancel out, and then I can put the 6.02 times 10 to the 23 atoms on top. All right, so now if I do the math here, what this will look like is 20 times Avogadro's number. That should be 0.0, divided by 22.99. All right, so when I put this in my calculator, I'm going to do 20 times Avogadro's number, 6.02, and I'll do, again, I'm using that E. And then I'm going to hit enter, and then I'll go ahead and divide that answer that I got, which is what's in the numerator, by 22.99. I don't think you actually have to hit enter in this case, but I always like to do it just so that, depending on the calculator I'm using, it doesn't give me the wrong answer. All right, so here's my answer right here, 5.237 times 10 to the 23. And if we're using sig figs, we have 3 sig figs, so 5.24, because the cutoff is a 7, times 10 to the 23. And that, of course, will be atoms. All right. Last two. How many moles of sodium contain 1.04 times 10 to 23 atoms? Sorry, 25 atoms. And that's our given. So we're given the number of atoms, and we're asked to find the number of moles. So in this case, we're starting here, and we're trying to go to moles. Our conversion factor is 1 mole equals Avogadro's number. So since I have one conversion factor, I'm going to multiply two fractions. The first fraction being the given, the second one's for my conversion factor. So I'm going to take my given, 1.04 times 10 to the 25 atoms over 1. And then in the second conversion factor, I want to cancel out atoms now. So now I'm going to take Avogadro's number of atoms, because I'm focusing on atoms there, 6.02 times 10 to the 23. That goes in the denominator, and then 1 mole goes on top. All right, so my atoms will cancel out since they're opposite. All right, so now what does the math look like here? You're going to essentially be dividing these two numbers. You're going to have 1.04 times 10 to the 25. And then you're going to divide it by 6.02 times 10 to the 23. And then when you do that, you're going to get 17.3 moles. All right, and I'll show you what that looks like in the calculator so you can see me put it in. So the math was 1.04 times 10 to the 25. So once again, I'm going to use 1.04, second E, 25. And then I don't need to enter it out, but if you want to, you can. And then I'm going to do divide 6.02, second E to the 23. And then you can see I get 17.27, but at 3 sig figs, it'll be 17.3. Now, by the way, if you were going to use the caret, so if you're doing 1.04 and using the caret, so like 1.04 times 10 caret 25, the important thing here is that you have to put that entire number in parentheses or the calculator will misread what you're trying to do. So, and again, if I'm using, so you see I put an open parenthesis 6.02 for Avogadro's number times 10 caret 23, close parentheses. All right, so that's the way that you do it if you're using the times 10 to the caret. Make sure you put your scientific notation values in parentheses, the entire thing. All right, last one. How much does this 1.04 times 10 to 25 sodium atoms weigh? So I'm starting with number of atoms, and I'm trying to find how much it weighs, so I'm trying to find mass. So I'm going from number of atoms to mass. Can't get there directly, have to go through moles. So first conversion factor is 1 mole equals Avogadro's number. The second one will be 1 mole is equal to the molar mass. So we have two conversion factors again. So we know that we're going to need to multiply 3 fractions. All right, so set up our 3 fractions here. So in the first fraction, I'm going to put my given 1.04 times 10 to the 25 atoms. And in the second fraction, I'm going to use my 1 mole equals Avogadro's number. I'm going to put Avogadro's number in the bottom so that the units of atoms can cancel out. That's a 23 times 10 to the 23, and then 1 mole on top. And then the second fraction, I have, so my atoms have canceled out. I have moles left now. So in order to cancel that out, I need the mole part of that second conversion factor. 1 mole equals the molar mass. I'll put the 1 mole on the bottom. So the moles can cancel out, 22.99 grams on top. So my math here looks like this. 1.04 times 10 to the 25 times 22.99 divided by Avogadro's number. And then if I put that in my calculator, I get 397 grams. All right, I hope you found this video helpful with getting you through these conversion problems. Have a quality day.